All right, this is from chapter 1, section 3, problem number 9. And we did a few of these in class. I thought I'd go over all of these in this video so that if you're struggling with these, I can help you. So now let's understand the directions clearly. Oops, sorry. First it says we're going to try to find the derivatives of these. And they want us to use the definition of limit, and of which there's two, and we're supposed to find the derivative at these different points for these different graphs. And then we're supposed to test our answer using a graph and drawing a appropriate tangent line, and then maybe even use technology to calculate it also. So there's 3 different ways, of which one of the ways has 2 ways. And we were working in class on just 2 of the ways. And so I want to go through like completely here so that you can understand all of the aspects that they're asking you to look at. So A is f of x equals x squared minus 3x at a equal 2. Now, let's just get an understanding of what's going on here. So I'm going to kind of do these in a different order than they're suggesting. I move the camera in a little closer, get this in the right place. And then I'm going to go to my calculator and type that equation in, which I did. And then I'm going to push graph. And they want me to find at 2 what the slope is. Okay, so I'm going to come down here and it's going to be at a point about there. Let's actually do trace, and we're going to get over here to where x is 2. I'm at 1.3, 4, 5, 6, 7, 8, 9. There's 2. And now I want to estimate it. They said estimate it just drawing a tangent line on this. So now I got to come up with a tangent line. And to do that, I'm going to lay a card over this. And I wish this was bigger for you, but it's kind of small on this calculator screen. So I'm trying to get this card to look like it's going to be a line that touches the curve at one point right there. Now this way it touches 2 points. This way it touches 2 points. To get it only touching 1 point, the line is going to, oops, I got 2 cards here. Line would have to go something like that. I'm trying to get a line that has the same slope as the graph does there. Now, if I've got it reasonably close here, I should be able to take and find 2 points. Now, this point right there, that one is 2, negative 2. So I'm going to write that down over here. 2, negative 2. The tangent line at 2 has got to go through that point, and it's got to go through another point. And I'm going to go, let's say, I'm going to pick that as the tangent line. And that line looks like it goes through 0, negative 4. But if you chose something here, it might be 0, negative 3.5. Or you could go 4, 0, or maybe 3, 0, depending on where you put it. So my original one was 0, negative 4. But there's a bunch of them. Now, what is the slope between these points? And so I'm going to take y2 minus y1 over x2 minus x1, and I get minus 4 plus 1 minus 3 divided by negative 2, which is a slope of 1.5 or 1.5. Okay? Now, let's see if we can, that's an estimate for the slope of the tangent line. That's an estimate for how fast this is going up as we go over right at that point. How fast is that curve changing at that point? Well, the reflection's bad. There, you can see it there. Okay, so now let's go to try to find that algebraically. Now we have the two formulas, f of x, f prime of x, or at a is the limit as b approaches a of f of b minus f of a over b minus a. Now I'm going to use this formula for this. So f, the original one with b in place of the x's, becomes b squared minus 3b minus all of this when I put 2 in. So I'm going to parentheses. This is f of b minus, then I'm going to put f of a in parentheses, and that's putting 2 in place. So I get 2 squared minus 3 times 2 all over b minus a, and a is 2, so I want to know what this happens to this as b gets closer and closer to 2. So now I'm going to do some algebra to simplify this. I'm not taking the limit yet, so I have to rewrite that. So I've got b squared minus 3b. Let's see, this is 4 minus 6, which is minus 2. So I have minus a minus 2, which is plus 2 over b minus 2. And this factors to b minus 2 and b minus 1. B squared minus a b minus 2b is minus 3b plus 2. And so the b minus 2 cancels, and I get an expression equivalent to this in most places, and that will be the limit as b approaches 2 of b minus 1. And this, I can put the 2 in. It doesn't cause the error that this would. And so I get 2 minus 1, which is 1. Now my estimate was 1.5. This is saying the slope should have been 1. Let's go back to the calculator here for a moment and put this at a slope of 1. Now a slope of 1, if I went through minus 4, it would have to go through 4 on this side. And they're saying what we just got says that's the slope of the tangent line. Now, they didn't say actually find the equation of the tangent line, but I'm going to do that since I have all the information I need. So this was off. The tangent line slope is 1, so I could say y equals 1 times x. Then it has to go through 2 minus 2. So if x is 2, I'm supposed to get minus 2. So I'd have to be subtract 4. So the tangent line would have a y-intercept of negative 4. I was off. Goes through negative 4. But that's the idea. Okay, but the rate of change is 1 for 1. Okay, let's do it the other formula. The one that generally works easier, and the one that I would expect most of you to try most often. The limit as h approaches 0 of f of a plus h minus f of a over h. So if we put a plus h in here, we get, we haven't done the limit, so I got to write it. a plus h in place of the x's, so I'm going to have a plus h squared minus 3 times a plus h. That's a plus h put in for both x's. And then minus f of a, so I got to put 2 in for both x's like we did before, so that's going to be, and this is the f of a plus h minus the f of a, which is going to be with 2 in, so that's 2 squared minus 3 times 2, and a should be 2 here, sorry, over h. So now let's algebraically work on that. So 2 plus h squared is, get it over here where you can see it. There. 2 plus h squared is 4 plus 2h plus 2h is plus 4h plus h squared. So I'm getting the limit as h approaches 0. I'm not working on finding the limit yet. I'm just doing some algebra to clean this up. So I got 4 plus 4h plus h squared minus 3 times 2 is minus 6. Minus 3 times h is minus 3h. You really have to watch your signs. And then this is 4 minus 6, which is minus 2. We got minus a minus 2, which is plus 2 over h. 4 minus 6 plus 2. 2 and 4 is 6. Minus 6, 0. And so I end up, I'm still doing algebra, I haven't found the limit yet, as h approaches 0 of 4h plus h squared minus 3h over h. I could have put these together and called it 1h, but h is supposed to go into each of these, and there's an h in each of these, so I can do that simplifying. I'm still haven't found the limit. I'm just still doing algebra, so I get 4 with h going in there and canceling an h, plus h, canceling one of the h's, and h going in there, minus 3. And now this, I couldn't put 0 in because it would have been division by 0. But this, I can put the 0 in for the h, and it comes out to be 4 plus 0 minus 3, which is 1. Same answers we got up there, 1. This has a slope of 1. Now, since I have this equation in the calculator, I can go and do a calculator estimate of the actual slope by saying if that's f of x, this one turns out to be the easiest because when I go to my tables, it'll always be the same. I'm always making h go to 0. Here, b has to go towards a, but here h always goes to 0. So I'm going to use this one for my calculator techniques, and it'll be set up right here. And this setup will be always the same. Now, for those of you who don't know yet, on, let's see, I'm looking for a spot that has the least reflection. There we go. You can make a fraction on the newer type calculators by going alpha y equal and choose numerator divided by a denominator, 1. And it'll set up an automatic fraction for you so you don't have to worry about parentheses as much. I want to put in f, which is actually in this case called y1. So I want to do vars y variables. The vars button was here. It's just under the arrows, vars, y variables, function. I press enter, and then I press that, and I get y1 with A. Now here's the only part that changes. I'm looking at 2, so I got to put in 2 minus 2 plus x, which I'm going to, 2 plus h, which I'm going to use x for the h in this, minus, and I close the parenthesis, and then I got to do y1, vars, y variables, function y1 of just the 2, parenthesis, 2, close parenthesis, over h, but I'm using x for the h. So now, I don't need to look at the graph or the table for this one. I can leave it on or I can turn it off. I'll leave it on for right now so you can see what happens. Now I'll show you both ways. I'll make sure my table sets on ask, and then I'm going to go to my table and I'm going to clean all of these out, and I'm going to put in numbers close to 0. Remember, x was my h, and I want it to get close to 0. So I'm going to put in 0.1, which is close to 0, 0.01, it's closer, 0.0001, really close. Boop. And I'm getting that kind of number. And I think I got my mode in something that I don't want. Math print, classic normals, sci-fi float. What changed it? Okay, I'm not seeing it. Okay, second clip. I don't know, second table. There, went to decimal there anyway. So, and let's 0.1, 0.0001, let's go negative 0.0001. And it's coming up with 1. 0.00001. It's telling me the slope should be about 1. And so that's using the technology to estimate it. This is doing algebra way, and this was estimating it by looking at a tangent line. So when we did it here, okay, we just found a couple points on the line that was tangent. Those are the 3 methods. One of these, this, and the technology. So now let's go to another problem. Let me move this back in a little bit so I don't have problems keeping the paper on there. All right, let's go to B, which was f of x equals 1 over x, and we want to look at a equal 1. So let's start with the technology. So I go to my window and I just say, okay, the function was this. Now it's going to be, clear that one out and put in 1 divided by x. And since I did this one, this is going to find it at 2. And I don't want to find it at 2. I want to find it at 1. So I'm going to put 1 in place of the 2's. And now if I go to the table, it's already got the right numbers. X is getting closer and closer to 0, and it looks like our answer to this one's going to be -1. Let's take a look at the graph. So now that I've got it in there, if I look at the graph, and they want the slope at 1, ignore this, at 1, does that look like it has a tangent line, a slope -1? And let's see, let's put it over here, that's better. And I don't want it to graph this. So I'm going to put it there, now graph. And I'm looking at the slope at 1. So if I draw it, does that look like it has a slope of -1? It does to me. Looks like it goes through 2, 0, 2, and 2, 0. So down 2 over 2, so that's a slope of -1. Okay? So I've looked at the graph, estimated it. I've looked at the technology. Now let's do the algebra. So we're going to have, I'll do both of them. The limit as b approaches a, which is 1, of f of b minus f of 1a over b minus a. So, haven't found the limit of 1 over b minus 1 over 1 over b minus 1. And the algebra says, in class, somebody said multiply numerator and denominator by b, and that works. I'm going to do a little differently. I'm going to get a common denominator in the numerator by multiplying by b and b, just so you see how this works. And I get the limit as b approaches 1 of 1 over b minus b over b minus 1 has a common denominator, so I subtract the numerators and I get the limit as b approaches 1 of 1 minus b over b divided by b minus 1, and that's denominator there. So now I can invert and multiply, or I can multiply both numerator and denominator by b minus 1. 1 over b minus 1. So that these cancel, and I get the limit as b approaches 1 of 1 minus b over b times 1 over b minus 1 over 1. That's what the denominator comes out to be. And again, we have this issue of how is b minus 1 different than 1 minus b? Well, the signs of this are just the opposite of the signs of this. So I can factor out a minus 1, and this becomes minus 1 times a b makes a minus b, and minus 1 times a minus 1 makes a plus 1. And now this looks like this and cancels, and I got minus 1 over b of minus 1 over b, and if I put in 1 into this, I don't get undefined, and I get minus 1 over 1, which is minus 1. Okay? So I did it with one of the methods. And in class I did it the other one with the h, and it gives you minus 1. So that's b. Now c we didn't do in class. So let's do c, where f, excuse me, f of x equals the square root of x. And we want to know the slope of this at a equals 1. So I'm going to my calculator. Go on the y equals, and I'm going to clear this one and put in square root of x. And this is going to be good, but I got it turned off right now. You see the equals not highlighted. Get it over here where you can see it. Okay, so let's just graph. And by the way, my window is zoom 4, zoom decimal. This makes a nice one for when I'm looking close to the origin at a graph. And I want to look for the slope at 1. Well, that looks something like this. Let's see. Something like this. Trying to look at the screen and see how it's showing up in the camera. There. And it looks like it's going through a half and then through 1, 1. So it's going up a half for 1. So it looks like a slope of about a positive 1/2. That's my estimate by looking at the graph. The slope of the tangent is 1/2. Now let's see if we can get that. Let's do the technology. So go to the y equals, and I'm going to turn this one on, and we want it at 1. So that's got to be a 1. And that's got to be a 1, which they are. And then if I go to my table, h is going to 0, and I get 0.5, which matches what I thought it should be. Now, let's do it algebraically. This one's a little trickier. So I don't care which formula you use. I'll just use the first one. So the limit as b approaches 1, b approaches a, of f of b minus f of 1 over b minus 1. And that becomes the limit as b approaches 1 of square root of b minus the square root of 1, which is 1 over b minus 1. Can I put 1 in here? I get division by 0. In fact, I get 0 over 0, which is, don't know. So let's see if we can do something here. And I suggested doing conjugate. And the conjugate of this, of a square root thing, plus or minus something, is change the sign in the middle. So, and I'll explain why we're doing this here in just a sec. When I multiply the numerator and the denominator by the conjugate of this, this will produce this. Square root of b times square root of b is b. Square root of b times plus 1 is plus the square root of b. Minus 1 times the square root of b is minus square root of b. And minus 1 times plus 1 is minus 1. These two cancel, so this multiplies out to be b minus 1, which is what that is. So this will cancel that. That was the point of this. And so now I get the limit as b approaches 1 of 1 over square root of b plus 1. And now I can put 1 in because I don't get a denominator of 0, and so I get the square root of 1 is 1 plus 1. I get 1 over 2. I'm actually doing the limit because I'm putting in the 1. And I get my 1/2. Now let's do it with the h. So we'd have the limit as h approaches 0 of the square root of 1a plus h. So that's 1 plus h minus the square root of 1 over h. So the conjugate of this mess is square root of 1 plus h minus, this is just 1, so plus 1 over the square root of 1 plus h plus 1. So I get the limit as h approaches 0. This times this square root of 1 plus h, this square root of 1 plus h is 1 plus h. This times this is plus the square root of 1 plus h. This times this is minus the square root of 1 plus h. So those two cancel. And then I have minus 1 times plus 1, which is minus 1, over h and square root of 1 plus h plus 1. These cancel. This h and this h then would reduce, and I end up with the limit as h approaches 0 of 1 over the square root of 1 plus h plus 1. And if h goes to 0, I got the square root of 1 plus 1, which is 2. And so I have 1 over 2, and I get the 1/2. Okay. Are you getting the idea? I'm hoping. So now if I go to D, let's put this here. D, we're supposed to do f of x equals 2 minus the absolute value of x minus 1 at a equal 1. So let's take a look at this. Now some of you may have not graphed the absolute value before, so clear. We're doing it at 1, so this is already set up. That's why I like doing this h1 here. But the equation is 2 minus absolute value. If I push math right there, and then go to number, I get absolute value, and this calculator has pretty print, makes it look like absolute value. Older ones will do ABS, parenthesis. And what's in there is, what was it, x minus 1. So let's graph it first. And we're supposed to say what the slope of the tangent line is at 1. Well, I'm looking at the blue graph here. What is the tangent line slope? Well, at 1, it's on a point. It teeters. Doesn't really have one tangent line. So I'm guessing there is an answer to this. This one you can't determine. Now let's take a look at the table. As we get closer and closer to 0, we get minus 1. If we come from the other side, from the negative side, it's plus 1. It's plus 1 or it's minus 1. Which is it? Well, let's take a look at the graph again. At this side, the slope is plus 1. On this side, the slope is minus 1. So it's minus 1, minus 1, minus 1, minus 1, minus 1 on this side, minus, 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 minus. And then all of a sudden, it's plus, 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 plus. And in between, it changes from 1 to minus 1, which is what the red's showing here. When you're bigger than 1, the slope is minus 1. And when you're less than 1, the slope is plus 1. This one you can't even do. Now, if you put it and try to do it algebra, you'll get two different answers because you have to write, to do the algebra on this, you have to write the absolute value as a piecewise function. So this thing changes at 1. Now, beyond 1, the equation of this equation is the line it's got a slope of minus 1 going through plus 3. That's the equation as long as x is greater than 1. And the equation has a plus 1 slope going through 1, so x plus 1 slope through 1 if x is less than 1. And we'd have to use this for all of those x's and this for all the other ones, this one will give us a -1 slope. This one will give us a +1 slope, which is clearly -1 slope and a +1 slope, and it changes right at 1. And one of these would have an equal on it, but that's a small thing. This one, you're not going to be able to get an answer algebraically that makes sense. It's going to change from one to the other. You'd have to do both parts of it in an equation, and you're going to get no answer. There is no derivative. There's no one slope at 1. Every place else there is, but not at 1. If they'd asked me to find it at 0, I would use this equation in there, and I would use y equals x plus 1, or f of x equals x plus 1, and go through the formula algebraically, and I would get a slope of 1. But clearly, this is a line, and the slope is 1, so I don't have to. I can tell the slope is 1. Okay. And finally, E. What if we have f of x, equals sine of x at a equal pi over 2? Well, if I go to my calculator and go to y equals and type in sine x and graph at pi over 2, which is 1.57, it looks like the slope is, get it here where you can see it, at pi, remember this is pi, 3.14, here's half a pi over 2, looks like the slope is 0. Just looking at the graph, if I drew a tangent line, the slope of that tangent line is 0. If I look at the table, as I get closer and closer to, got to go here, and now I don't want it at 1, I want it at pi over 2, so I got to change these 1s to pi over 2. So I got to go second pi, insert, divided by 2, and pi divided by 2. And now second table, I've got it there. When this h gets close to 0, I'm getting 5e negative 5. 5e negative 5. What's that mean? Well, that's saying 5 times 10 to the negative 5, and 10 to the negative 5 is 1 over 1, 2, 3, 4, 5 zeros. So 500 thousandths, 0.0005. Oh, dang, that's looking like it's getting really close to 0. Those are a little bit hard to read because you have to understand your exponential notation. And if you were to try to do this algebraically, you'd have, let's do f prime of at a or at pi over 2 would be the limit as b approaches pi over 2 of f of b minus f of pi over 2 over b minus pi over 2. And f of b would be sine b minus sine of pi over 2 is 1 over, I forgot my limit. Bad. Over b minus pi over 2. To algebraically try to simplify this so that we could get rid of this is a problem. And so this one doesn't easily solve with algebra. Just like the absolute value has a problem, solving with algebra. This one also has a problem solving with algebra. So they're not expecting you to be able to do that one or this or the absolute value one. So, but the slope at pi over 2 is 0.